Let's get this lesson on trigonometry started with a great joke. What type of math do trees do? Of course, trigonometry. Let's have a look at the right angle triangle for a moment. Trigonometry only uses in grade 10 the right angle triangle, so note the 90-degree angle in the corner. Also note the label A in the bottom right-hand corner of the triangle. That's our reference angle. So a reference angle will always be one of the two acute corners, and it will be named a letter. It could be named a Greek letter, or it could be a number, for example, 32 degrees. From our reference angle, we have to label the sides. So the easiest one to do is, of course, the hypotenuse. The hypotenuse is the longest side of any triangle, and it's opposite from the 90-degree angle. The opposite, now imagine standing at the reference angle and throwing a ball straight across. That would be where you would be throwing it to the opposite. And of course, another word for adjacent is beside. So the side that is beside the angle will go right here. Now, let's have a look at a second triangle. Notice that we've moved the reference angle from the bottom right to the top left corner, and I've called this reference angle B. Now, what happens when we label the sides from a reference point? Remember, hypotenuse is always the longest side. If you're standing at B and you throw a ball, where does the ball go? Well, it goes straight across to the opposite. And which side is beside the angle side? The adjacent. So notice that when you are labeling it from a different reference point, you have the adjacent and the opposite switching. The hypotenuse never changes. It's always across from the 90-degree angle, and it's always along the side of the triangle. Let's have a look at one of the trig ratios. The first one is sine, S-I-N-E. So what we're going to look at is four triangles, and we're going to look at the way they've been labeled. So let's have a look at these triangles. So for example, if we start at this reference point and we go across, we find that this is the opposite and this is the hypotenuse. So from that ratio, we have those two sides marked. Okay, let's have a look at the next one. From this reference point, if we have these two sides selected, from here on this side, this is the opposite, this is the hypotenuse. All right, let's carry on. If we have these two sides selected, from the reference angle, look straight across. This is your opposite, this is your hypotenuse. And let's look at the last one. So from this reference angle, if these two sides are selected, again, we have an opposite and we have a hypotenuse. So let's have a look and summarize what we know about sine. So now we can make some assumptions. The sine ratio only uses the two sides, the opposite and the hypotenuse. So the sine, which is the trig ratio, of some angle. Now the angle might be written as a number, 32 degrees, might be written as a Greek letter, maybe called theta, maybe as a variable like x, is equal to opposite over hypotenuse. The opposite and the hypotenuse refer to the lengths of the sides of the triangle with those two variables. All right, let's look at our second ratio, cosine. Again, if you have a look at the screen, we have some triangles, and I figured out how to put red dots for reference angles, so here we go. So from the reference angles, you can see that from this reference angle on the first one, this one here, we have nothing on the opposite. So this time we have the hypotenuse worked out and the adjacent. So what we have is the adjacent and the hypotenuse. All right, let's go to the one on the right. Again, from the reference angle, you can see that we have a hypotenuse and an adjacent. So here's my hypotenuse, and here's the adjacent. All right, from the next reference angle, you can see again, nothing on the opposite. So this is the hypotenuse, and this is the adjacent. And our last one, again, nothing on the opposite. So this is our adjacent, and this is our hypotenuse. So you can make some assumptions now that the ratio for cosine has only to do with two sides, A and H. And if we use the same pattern as before, we'll find out what the cosine ratio is. All right, let's have a look at the cosine ratio. So the trig ratio first, so cosine, again, this time I've used theta for the angle, but we could use a capital letter. We could use 22 degrees. And the ratio is the length of the adjacent over the length of the hypotenuse. So that's your cosine ratio. All right, here's our third ratio, the tangent ratio. Have a quick look at all the triangles and see what side hasn't been ticked. You got it right if you said the hypotenuse. So in this case, you can see that from our reference angle, we have an opposite and an adjacent. We have an opposite, adjacent, opposite, adjacent, and opposite and adjacent. So the two sides that have anything to do with trig ratios are O and A. All right, let's have a look at the tangent ratio. So the tangent ratio, the tangent of theta, again, could be a letter, could be a number, 25 degrees, is equal to opposite over adjacent. All right, let's quickly talk about sohcahtoa. You may have heard some of your older brothers or sisters talking about sohcahtoa. So sohcahtoa is a mnemonic device that helps us remember the ratio and the connected sides. So stands for the sine ratio, and the two sides opposite over hypotenuse. CAH stands for the cosine of the ratio is adjacent over hypotenuse, and the T stands for tangent, stands for opposite over adjacent. So before you go any further, please make sure you've memorized all the ratios. You can identify all the sides, and we need to know that before we go any further. Let's just have a look at the structure of a trig ratio. So now that we know the three ratios, you're always going to start with either one of sine, cos, or tan. The next piece of the puzzle beside that goes the angle. Now, the angle might be a number, let's say 76 degrees. It might be a letter, capital A. It might be a Greek letter, theta. You always have the equal sign. It's equal to the ratio. Now the ratio might be a fraction, for example, 4 over 5, or a decimal. The decimal might be 0.345. So we're going to talk about in a minute the values that these decimals can take on, but this is what every question should have. A ratio, an angle, an equal signs, and a ratio in the form of a fraction or a decimal. In trigonometry, we definitely need our calculators or we need trig tables, which we'll talk about later. But for now, this is going to be a big moment for you. You can finally use the buttons right here, sine, cos, and tangent. You'll also need to know your second function key or shift key on your calculator. Please make sure that your calculator is in degree mode. So if you can find your mode button, make sure somewhere on your screen, although I can't see it on mine, it says D, DRG, or DEG. All right, let's actually get to work trying to find some ratios. So I've given you a triangle, right angle triangle with a reference angle called A, and I've given you side lengths 1, 1, root 2. When we're finding side lengths of right angle triangles, we always use Pythagoras to find the missing side, so that's why everything is still in its square root, and I would prefer it to be in that form. So let's go ahead and start with our basics. What do we do firstly when we find a triangle is we label the sides. Well, we're standing at A and we throw a ball. This becomes our opposite. The longest side is always the hypotenuse, and the side beside the angle that we're talking about is the adjacent. Now we can see that A has a length of 1, opposite has a length of 1 unit, and hypotenuse has a length of root 2 units. So we can remember our mnemonic, sohcahtoa. I prefer it written in this form rather than a horizontal form so that we can see the structure of the trig identities. And here we go. Sine A is equal to opposite over hypotenuse, which is 1 over root 2. Cosine is equal to 1 over root 2, adjacent over hypotenuse. And A is opposite over adjacent, which is 1 over 1, or just 1. Let's take that same triangle and just add a bit of information. This is a special triangle. It's an isosceles triangle, and the corners are 45 degrees in each corner and 90 in the right angle, of course. So now what I'd like you to do is I'd like you on your calculators to find out what is the sine of 45 degrees. I'll wait while you do that. All right, this is what you should have on your calculator. You should have the sine of 45 equals, and if you notice I have degrees here, 0.707106781. So that's the ratio of the sine of 45. So let's check that against the answer that we got in the previous slide, which is the sine of some known angle, sine of 45 degrees, equals 1 over root 2. So go ahead and put 1 over root 2 into your calculator. Well, what have we just discovered? That 1 over root 2 is actually 0.707, etc. So we've now found out that our calculator has a way of finding out the ratio for every known angle. And I'm going to tell you how it does it. Alright, not only can we use our calculators to given an angle to find a ratio, like for example the sine of 45 equals, we can ask the calculator what angle gives us any given ratio. So for example, let's pretend for a minute that we didn't know what angle gave us 0.707. So on our calculator, we have to find the shift or the second function button, and then we have to make sure that when we enter it, we get this little notation here, the -1, sine -1, and we enter in as many values of our ratio as we can, the better. And then we hit enter, and notice how it gives us 44.9. So it's very close to 45 degrees, and that's just because I didn't put in all the decimal places. So using second function will give you the angle given the ratio. This is a very helpful function to know how to use. Let's have a look at the sine curve. So if we're plugging in any angle, that's a sine ratio, using the two sides opposite over hypotenuse. This is the graph that your calculator has inside its little brain. So if you want to know what the sine of 0 is, well, the sine of 0 is 0. Well, let's say, what is the sine of 90? The sine of 90 is 1. What is the sine of 180? 0. What is the sine of 270? -1. And what is the sine of 360? 0. So as you can see, a couple things are happening, pretty important things are happening. We have positive values on the top side, and we have negative values on the bottom. But if you have a look and notice, the top of this starts at 1 and it goes to -1. So the only values we're going to have for sine are between 1 and -1. From 0 to 180 degrees, those are going to be positive. And from 180 to 360, those values will be negative. So you can use this curve to estimate the sine value of any angle. So for example, if you want to estimate the sine value of 50 degrees, we go to 50, we go up, we go across. I'm going to guess it's about 0.75. So you can go ahead and check that on the calculator, sine 50 equals, and see if I'm close. Well, let's see if we can do the sine of 100. So the sine of 100 is just less than 1, so I'm going to be optimistic and say about 0.98. So go ahead and put in sine 100 and see if I'm close. We can also estimate values on the negative side. So for example, if I want to estimate the value of the sine of 200, well, 200 is around, I'm going to go with negative 0.35. So again, you can plug in the sine of 200 and see what you get. The nice thing about this graph is you can also go backwards. So this is exciting. We can go to a value and say, give me a value for sine that is about a half. Okay, so here's a half, and then here's this. So that's about 30 degrees. So you can check that. How you check that on your calculator is you do second function sine, so second function sine, or shift sine of 0.5. Your calculator is going to give you the first value on the graph, and then we'd have to calculate the distance between those 2 points for our second value, but for now, that will get you started. We'll talk more about second function later. Alright, here's the cosine curve. If you notice, the curves look similar. These are essentially the same curve with what we call a phase shift. The graph's been moved over a little bit to the left or to the right to get the second graph. So let's play the same game. Well, what is the cosine of 0? Well, the cosine of 0 is 1. These should actually go up in 90s. So this is the cosine of 90 is 0. 180 is -1 right to the bottom. This is 280 is 0, and 360 is at 1. So you can do estimations from here as well. So let's estimate what is the sine of 50, or sorry, the cosine of 50 degrees is about zero point 0.6, I would give it. Let's do some of the negative values. So the cosine of 150, oh, that's going to be negative maybe 0.89. So you can check that on your calculator. And this side is positive again, so the cosine of 300 degrees looks like it's at exactly 0.5. Again, look at the highs, 1 and minus 1, and the middle line here is 0. So from here you can see that the values of cosine again go as high as 1, as low as minus 1, and this time we have positive at the ends and negatives in the middle. So you will get positive and negative numbers from 0 to minus 1 for cosine. A lot of students ask me why I don't talk to them about the tangent curve, because the tangent curve has a lot of problems. One, it's not a continuous graph, and two, you have to know about restrictions, and it's not as easy to do predictions from this graph, although you can see that there are some values that we could find. So generally speaking, when we're using our estimation tools for trigonometry, we generally only use sine and cos graphs, but one thing that I always talk about is we can use the ratio of tan theta is equal to sine theta over cos theta, which means that if we're estimating, for example, the tangent of 65 degrees, if we find an estimate for the sine of 65 and the cos of 65 and divide them, that will give us a pretty close value to tangent. So if you want to try that for tangent, go right ahead. All right, let's start by trying to solve an actual problem. So a lot of trigonometry problems have to do with simple things like ladders and walls or ramps and stairwells, different kind of things where objects are leaning against other objects. So let's have a look at this question. Suppose it says a ladder that is 9 meters long is leaning up against a wall and it's leaning at an angle where the ladder hits the ground at 27 degrees. The question is how far up the wall does the ladder hit? So you have to try to visualize a building here, a little bit of a building, and this is your ladder here. So better diagrams often help. So from our reference angle, we know it's 27 degrees. So what we're going to start looking at is the basics of trigonometry. From this reference angle, what sides do we have? Well, let's have a look. From here, from our 27, if we go over here, you think ahead of me, I'll just put them there. You got it. You got it right if you picked opposite for the wall and the ladder represents a hypotenuse. So, going back to basics, we have to ask ourselves, what ratio uses opposite and the hypotenuse? Well, we know the first ratio uses that. So it's the sine, in this case of 27 degrees, equals the opposite. But remember, we don't know what the opposite is, so we could call that x. And we know that the ladder is 9 units, could be 9 feet, 9 meters high. So now we have to solve for our unknown. So if we apply basic algebra and we multiply both sides by 9, we now get x is equal to 9 times the value of the sine of 27 degrees. So a couple ways you could do this. You could do, depending on your calculator, sine of 27 equals times 9. And you could use an estimation from the table or from the chart or the graph we talked about earlier. And I apologize, I've forgotten my calculator, so I will stop this while I go get it. Alright, as you can see, I punched in 9 sine of 27, and it equals 4.0859. So what that means is the ladder reaches about 4 units, or 4 feet, or 4 meters up the wall. So we've now done our first trig problem. Alright, let's have a look at another problem. Again, keep in mind that all trigonometry problems are in the context of a ladder or a ramp or maybe a book leaning up against a shelf, so that will be the context of the problem. So once you have the diagram drawn, we start by the reference angle. So here we have the reference angle is 53 degrees. Now we have two sides, an 8 and a y. So the first thing we have to do is always figure out what's what. Well, the 8 is beside the angle, so it's your adjacent, and the y is on the longest side, so that's your hypotenuse, and there's nothing on the opposite, and that's okay. So going back to our basics, what do we know about a and h? Well, a and h have to do with the ratio cosine. The cosine of 53 degrees is equal to 8 over our unknown hypotenuse. Now, notice, if you will, that the cosine of 53 is equal to 8 over y is in a different form than the first question. Our unknown value is now missing on the bottom. So there's a few ways that we could solve for this, and we can do this in a two-step problem. So the first way is, let's move the y to the other side. So multiply both sides by y. So you get y cos of 53 degrees equals 8. And now we have to divide both sides by cos 53. So y is equal to 8 divided by the cos of 53 degrees. Now, in a very unmathy kind of way, I call this switcheroo. Because if you notice, the y is now where the cos 53 is, and the cos 53 is now where the y is. So when the missing piece is on the bottom, in the denominator, which starts with d, we do the operation division. All right, let's see what we get. All right, and if you plug that into your calculator and you do 8 divided by cos of 53, you get 13.29. So let's always leave our answers at 2 decimal places. And so now we know the length of the hypotenuse, 13.29 units. All right, let's look at the third type of question for trigonometry. The first two are missing sides, depending on where they were located in the ratio, and the third side is a missing angle. Now, first steps we always start with. We start with the basics. We look at our reference angle. In this case, our reference angle is z. It's an unknown value. So from z, we label our sides. So we can move our opposite here and our adjacent here. So now we have opposite and adjacent, so we have the ratio tangent. So from here we can fill in the missing information. The tangent of z is equal to opposite over adjacent, which is 6 over 15. Now, in previous discussions, we had looked at how to go from the angle to the ratio. Now, this is how to go from the ratio to the angle. So in this case, we will use our second function, tangent, or shift tan, and it should look like this in your calculator. And this operation will give you the angle size. All right, have a look. If you put in tan second function, you'll get the -1 notation. 6 divided by 15, you get 21.80 degrees. So that means the angle for our reference angle Z is equal to 21.8 degrees. All right, thanks for watching this really long video about trigonometry, but this is essentially all the information you need to know for grade 10 trigonometry. Step 1, don't forget to label the sides. Step 2, pick your ratio. Step 3, write out your ratio with all the parts, the name of the ratio, the angle, the equal sign, and the value. And the third part is to solve for missing pieces, maybe a missing side or a missing angle. With these basic tools, you're now able to progress to our next video, which will be on solving trigonometry word problems, when you're given the word problems and you have to draw the diagram, or when you have 2 or more triangles involved in the problem. So, I hope you enjoyed this trigonometry video.